I don't know why the Discord bot isn't doing its notification thing. Oh, there it goes. Puts good morning. What's up, Jomi? How you doing today? What's that? That's C, right? Put string? Sounds like C. What's up, Shahzada? Shahzada? How you doing today? I'm from Bangladesh. Awesome, that's cool. How do you like it there? Oh, tomorrow's your first day at work, Jomi. Nice. It's Crystal or Ruby. Either is fine. I thought C had put, or maybe C's got put C. Yeah, welcome to the stream. Oh, I guess you didn't have parentheses, so that's why. Also, my cats learned how to, yeah, they have the parentheses. My cats learned to jump up on my desk when it's in tall mode, so yeah, they're getting a little bit more acrobatic, I think. Oh, it's Crystal. What is Crystal? I know, they are adapting. So this is Crystal, huh? I feel like I've heard you guys talk about this. I'm torn on name spacing things like this. I do like that it's different than the dot, but I also don't like that it's different than the dot. You know what I mean? Like, I don't like that I have to do this other weird thing. But it's like Ruby, but statically type and compiled. Oh, it's almost one-to-one Ruby. Oh, interesting. That's cool. I never really learned Ruby. I did a little bit of Ruby, but not a lot of it. Not a lot of it. I'm torn on whether to use mod dot something or mod something for my language. Yeah. The advantage of the colon is that now it's unambiguous of which it's unambiguous whether or not you're a object referencing its variable or a package referencing its member function or something like that. Even though those are like kind of similar concepts, and you have less collisions with naming. Like sometimes in Go, I'll have collisions with naming stuff just because of that. What will I discuss? Well, this will be me trying to solve problems. So I'm not very much discussions. If you watched yesterday's stream though, I talked about a lot about how we're gonna be implementing this. But basically we're doing this, I think I've figured out the generalized problem. I guess I will discuss a little bit. Sorry, excuse me. The problem that we have when data comes over the network, especially a lossy network where packets get dropped and stuff like that, is that you have these clumps of packets that come in, and then there can be a big gap, and then there can be a tight clump of packets, a big gap, and a tight clump of packets. And when we interpolate this on the client, like this data is coming into the client, you know, when this data comes in, if you just interpolated these on the same time scale, what that's going to look like is it's going to look like kind of a smooth, or let me do this. That'll look like kind of a smooth movement. Like these are positional updates, by the way. So you have like this smooth movement, and then it just stops, right? Until you get to here, or let's do a graph maybe. You're kind of moving smoothly, and then you stop. Then you go really fast, then you stop, and then you go really fast again, then you stop, you know? So that's what ends up causing, and this is caused by network jitter, which is basically packet loss, which causes retries, things like that, or just like differences in packet routing and things like that. But so this is the problem, and the goal of what we try to do is what we want to have happen is we want to have like these equidistant points. So to the user, it looks smooth. It looks like a smooth interpolation along the distance. This is kind of like a 1D graph of you just moving in one direction. Like this is what we want to have on the client. So how you accomplish that is you basically build a queue. and you enqueue data, and then you dequeue data. You dequeue data at a kind of an equal distance point, or you dequeue data in the same interval, and that gives you this smooth pattern. But you enqueue data kind of all over the place a little bit. But because you have these clumped of packets, you basically just want to make sure that this gap isn't long enough to where you're going to starve this queue. Yeah, you can have duplicated messages too. There's a bunch of problems you can have with the network, but it's generally jitter is what causes this sort of pattern or this sort of behavior. And I can kind of show you what I have right now. So I have a lot of debug printouts, but so you see how it kind of like moves and snaps. This is like, I'm currently trying to fix it, but this is kind of what you start seeing. And you can also have drop packets. So when you have a dropped packet, what that looks like in this diagram, what a dropped packet would look like is like, this packet just never comes in. And the thing I was doing yesterday, I was trying to figure out the time scale that these should be on. And what I ended up changing from yesterday is now I include the tick ID, which is just a number, like 1 and 3. So now the client will or to determine the timescale that we want to interpolate on, you basically have like every tick should be like, let's say it's 16 milliseconds. And what I do now in my queue is I store the tick number as well as the position that you're interpolating to and from. So now that we have that data, we can basically see like, is the tick number changing by 1? Then do 16 milliseconds to interpolate with. If it's changing by 2, like if packet 2 gets dropped and we only have 1 and 3, now we need to know. Now we know we just need to interpolate for 32 milliseconds because it's a longer distance. So. Try standard out print. Good morning. I don't know what that is. What has standard out as like a global? Or is this C++ or something? Also that dot print, that dot brackets confuses me. I don't know that. Oh, that's Zig. Jeez. What's up, Mountain Shark? How you doing today? Hope you're having a good one. What's up, Kai? How you doing? What's going on? Not much. Just trying to solve this problem. So the weird thing that I'm having though is finding this number should be very straightforward because this should be the rate at which messages get sent from the server to the client. But it turns out that for some reason using 16 isn't the right number. The number I'm using isn't right. So like what I'm having happen is like it's interpolating and then it's waiting and then it's interpolating and it's waiting and it's interpolating and it's waiting because this number is just too low. So I'm trying to figure out why that is. So hence all the printouts. Oops. Hence all the printouts. Let's see here. I need to refresh my memory with what these printouts mean. Delta tick. So this one's calculating the difference between the last 2 ticks that we got. One weird thing though. Let me look at one thing. I want to make sure I know how the ticks are being incremented on the server. Or maybe it's in the network file, network.go. Sorry, no cat cam today. Will be just a programming stream. What's up, kid? What up, Kenta? What up, Kenta Conifer? So server tick gets updated here. And it's interesting how I slow down the server tick rate is really hacky right now. I'm basically just doing a modulo 4. So 16 milliseconds is the physics tick number. And then I mod for it basically. And then I only execute this logic of sending an update to all the clients if we've hit this mod 4. And this isn't like the right way to do it, but this is what I'm doing right now just for testing purposes. Because before it's sending at a 60 hertz basically, and that's just way too high of a tick rate. So yeah. Not even the hand cam, getting real lazy. Yep. Today's not my normal stream day, so I can be as lazy as I want. In fact, I can just not even talk. You guys just watch me type. You see things update, but I pretty much talk to myself anyways when I code, so it's not that bad. So I'm only incrementing the tick when only for test purposes, continues to production. Hey, yeah, there's been a lot of that in my life. That's just what happens. When something runs long enough, you know it's pretty much good enough. We can't watch you type, there's no hand cam. Yeah, I mean, you can watch the characters update on the screen. So this is more like a network tick and less of a, imagine his slick hands. Yeah, do I have slick hands? Type on his sliced keyboard. Yep. Oh, I like that meme you sent this morning of the guy typing with his feet. Gets sweaty thinking about it. Uh-oh. This is getting a little questionable there. I don't judge though. I don't judge. I just listen. But anyways, for some reason, it's kind of a weird pattern that I'm seeing. And I can kind of show you guys what I've seen. Let me just move downwards. But basically, server send update happens. This is like when the server sends the update. There's only one client right now, and this is all, the logs are all mangled together, server and client. What are we working on? You have to rewind 15 minutes so I can and watch me re-explain it. But we're trying to smooth out the network movement for high jitter clients. So that we're adding some client smoothing for people that have a lot of jitter, aka you guys in Europe, because it looks good on it works on my computer, but not on yours. But anyways, this is the server sending it. This is when the client receives the update. So these should be one-to-one. So we want to look for that. We also want to look for this to happen. Like these should all be at the same cadence, I guess. And this should be at the same cadence. It works on my PC, solved all the problems. Yeah, let me send my PC to people who want to play the game. Works here. The thing is, if I send my computer to you, it probably wouldn't work just because of the distance you are from the server. Even my ping's high. My ping's like at 116 or something at peaks, which is really high. He's finally thinking about us. I wouldn't go that far. Yo, unit, what up? If your ping is that high, I think it's a server problem. Even when I'm localhost, it says it's got a high ping. I think there's just some get a new server and don't blame it on us Euro chads. That's true. Well, I guess my server's in Chicago, which is kind of far from me. But even when I run it locally, I'll show it next time, but you can see the ping up here. I think it's like this, and this is like local. I guess I do have latency enabled right now, so. But I think there's some lag implicitly with having a proxy server. So I told you to get Hostinger. Yeah, I know you did. But I think I actually think Hosthatch, which is what I'm using right now, is a little bit, or it's like the same price, but I think the computers are a little bit faster on Hosthatch. And I already have it set up on Hosthatch, so. So I'm gonna stick with Hosthatch for now. Hostinger did seem like a good deal, but host hatch is also a really good deal. I think eventually I'm going to switch to Volter though. Because it's hard. If I do need to have like a load balancer or something like that, I don't think I can do that with a lot of these smaller VPS hosts. So anyways, anywho. Excuse me. Okay. So let's look at the cadence of these and just make sure that they kind of line up. But what I was seeing was that every other time there would be two pulls out of the queue and one push into the queue, which is making me like starve the queue a little bit. And I don't want that to happen. All right, let's see here. See, there's a sends. Let's look at this one. Let's look at this section. Okay. Server sends, client receives, and client gets a new tick. Server sends, this is probably from the last section. I'm gonna pull out the expecting. Well, let's just keep looking. Server sends, client receives, got one, expected it. Server sends, client receives. See, then the client receives again. And then server sends, expect one, client receives. This is the problem, is like, I don't know why this is happening. It's like every once in a while, it'll pull two packets out. So that means that I'm reading like slightly too fast. I wonder if it's caused by this subtraction that I'm doing. Let's just, it's still gonna look jittery probably, but that might be for a different reason. No, see, I'm still having this behavior where it'll send and client's gonna receive twice. Oh, there's always a cat war going on, dude. I just got a little Christmas tree too, and these cats love that thing. All they want to do is climb the Christmas tree and like fight each other in it. It's like the war zone. It's like the little bit of woods. It's like their I don't know how to explain it. They just hide. They like to hide in there. The little one does. The big one I don't think fits. I think he'd break the branches if he tried to if he tried to climb that thing. I wonder if it's only happening when this gets set high. So that might mean that I'm oh wait, got network tick. That's actually okay as long as I don't. Let's go here and let's clean up our logging a little bit just so it's a little bit more straightforward. Client 2, which is a terrible name for a file, but that's okay. Log.print. Okay, this is when we get a new network tick. And this is when we pull one out. I don't really know how to improve this. And then we calculate the wait a second, delay. Oh, this is the delay. That's the interp with time. I guess let's run it really quick. Okay. So it doesn't matter. It doesn't matter this. What's up, Doru? How you doing today? Newton bootin'. Oh yeah, buddy. We're always Newton bootin'. Or sometimes we boot and newt. Okay, so whenever we see this, it's pushing a network tick. This is the client receiving it. This is him pushing it into the queue, and this is him pulling it out of the queue. So he pushes 2. He pushes 2. And then he pulls 1. Too short means we're trying to extend the buffer, so we make the delay a little bit longer. So when we see this, we can kind of expect slightly different behavior. Let's see here. Actually, let's do, maybe I remove this delay logic. And then I just want what I want to see have happen is I want to see the I want to see it like perfectly line up. That's what I want to see. So we'll remove that section. This is what changed the delay. It changed it by like 3 times what the average tick time is. I just go downward so I can have a little bit of data. Okay. So when we see none to remove, that means the queue's been starved effectively. And the delay logic means that the starvation doesn't happen basically because we make the delay bigger. But we don't want to see the queue get starved. So the queue getting starved is actually the problem. Like we want it to be basically almost never having this message pop up, I think. Let's see, none to remove. Let's see here. Because once we pull one out, well, once we have 0 lag, let me do that. So I'll change it to 0 lag, then we shouldn't, because once we have jitter, it's kind of all bets are off. So, oops. You can see there's like still some spread there, which is kind of weird, but. All right, let's see. Okay, server send update. So that what the timer should do is the timer should restrict us from pulling until approximately the next one comes in. So the server sends one, the client receives one, he pulls it, there's a delay of 1 tick, which is basically size 0. Then he interrupts for 64 milliseconds, which is 16 times 4, which is basically 4 times our physics tick rate, which is right. So he should be waiting that time. But then he's doing 2 more pulls. So it's like he's doing 64 plus 16 plus 16. Because each of these is a different physics tick. Where the timer finished. The timer finishes here, you know? The 64 milliseconds finishes here. And then he tries to pull again. And then he waits 16 more milliseconds and he tries to pull again. And if I set this to 0, it might actually increase the number of times he tries to pull. So there's something about the timers. Yeah, that I'm not sure about. I don't know if the server's not sending at the right rate or the yeah, I'm not really sure. It's very strange though. And this is the repull. But the problem is like this is the general problem. It's okay if there's one of these every once in a while, but the problem is it's happening every single tick, which means that the timing is off. So what we're going to do next, I think, is we're going to calculate the average of the there's the send side, the server side. I'm going to calculate the average of that and look at that and make sure that that looks like 64 milliseconds. And if it's not, like the way I probably will eventually do this is I'm probably gonna on the client track the average time, some like moving average of the time that these ticks usually take, and I'm probably gonna guesstimate it based off of that. The reason I'm looking into this more is like I'm just confused on why this isn't lining up with what I expect to have happen. Because like we could just track the average and we could be like, oh, it actually takes like a little bit longer usually, so we'll just wait that distance of time, you know? We'll wait an extra tick or something like that, and then it'll probably look pretty smooth. The problem is like it's moving there, it's getting to its destination, and then it's stopping, waiting for like 16 times 3 milliseconds. Whatever that number is, 48, I guess. No, is that 48? I don't know math. Oh, it is 48. Look at that. Look at me. Look at me. Jeez. Damn, I'm good. You know? That was right off the dome, too. At least you admitted. Hey, but I got the answer right, so I'm gonna redact my admission. Yeah, I know my eights timetable. So hyped. Yeah, so it's waiting 48 extra milliseconds, which is kind of the confusing part. It shouldn't be waiting that long, so let's look into why that is happening. So this is on the server now. And this should be this should be happening every this should be called every 16 milliseconds, which is my fixed time rate. Let's track the time here. I'm gonna do this. This could point to my because I have like a system scheduler that runs my systems, and I wonder if that has a bug in it, which is making me send at the wrong rate. Got a shit meeting coming up. My lunch is gonna be cut by 10 minutes short. Uh-oh. That sucks, dude. Let's do this. Var, I'm gonna call it last time. Last time, I'm gonna do it last time 4. So we'll do last time equals time dot now. No, wait a second. Yeah, that's right. Time dot since last time. So this will be the delta between each time that this function is called. Then we'll have last time 4. Time since last time 4. And this should be the time between every single time we send. Well, that didn't work. What was the error? Oh, it's actually time.time. But this should print out our duration. It would be great if the bug is caused by units pro math skills. Jeez. That would be pretty cool. Honestly, I would take anything at this point. I'd be fine if like I hard coded a time duration somewhere else and like, oh, it's that stupid of a problem. Because that would at least mean I kind of understand what I'm doing. Well, also, what the heck is this? Oh, I never do this. That's right. It's also weird. These are... Yeah, that's not good. That's not correct, I don't think. 31. What's 31 times 4? Or it's actually pretty close to 32. 128. So that means that that's correct based off of this. Why 127 in the beginning though? There's always gonna be like a little bit of slop. Like it's 32 is the number, but sometimes it runs a little bit faster, sometimes it runs a little bit slower. I must have a problem with my system scheduler. Maybe I should write a unit test for that. What did I want to do? Oh, I wanted to look at 64 plus 48, 112. Well, we know that this is running at the wrong time, right? And I have my main like config. This is kind of a config file. I have my fixed time step, which is 16 milliseconds. And I set that to my scheduler. He said the thing. What thing? Is it on the bingo card? I'm betting 5 new coins on some timer being fucked. Oh, there's definitely a timer that's getting fucked. So this is, well, actually, let me go back here. Set fixed time step. I have new scheduler. And then I set the fixed time step on that scheduler, and then I return it. This is my scheduler thing. And I have input physics render systems. The physics system is what this should be a part of. Let me just double check that really quickly. Let's do the, actually. sys.go. Guess it's in here. Server systems. Create server systems. Yeah, server systems are in the physics tick. So they should be running at a fixed time step of what I set my fixed time step to, where I set this to 16 milliseconds. All right. I guess I've been running it at 30 hertz. S.fixed time step. Let's just make sure I'm using the right one everywhere. Have fun, unit of tests. Thanks, Conifer. You have a good one. Good luck with your meeting. I hope it goes smoother than you anticipate. I really should get rid of this old. This was my old way of doing it. Let's get rid of this stuff. And let's just make sure that this still runs. Uh-oh. Oh, that's because of that. This is just in the menu. Stupid meetings wasting my time. I know, buddy. I know. I want to append render. So we'll make a scheduler. We'll append render systems, which are those, and we'll run that. And that should be remove this. Oh, that's typoed. Okay, that was just the menu, but at least that at least let us remove that piece of code, so I know it's not conflicting at all. Because that was like an old way of how I ran systems. Okay, so let's look at this code now. Don't play with that. All right. So what we have, how this works is there's fixed time systems, and then there is like dynamically timed systems. And dynamically timed systems are basically run as fast as they possibly can. And they're kind of synced with the render system. So whenever the render finishes, it basically restarts this loop. The problem with that, one downside, this shouldn't happen on the server though. One downside of that is that if the render takes too long, you can build up a lot of delta time inside of your what I'm calling the accumulator, and then you have to run the physics system multiple times to like counter that. You know, it's kind of like a very similar problem to what I'm dealing with on the other side too, where you want this to run. These have to be run at the same time, so this runs with the same physics fixed time step. The problem is these are run 32 milliseconds apart, which isn't correct. Am I doing like a sleep or something? I must just be like calculating this wrong. How it works basically though is this loop will run and accumulator will build up time, like for the physics part, you know. Everything else is running as fast as possible, and DT is used. DT is not fixed time step the whole time. Where is DT used? We run it with the DT. We run the render with DT. So input gets run with DT, render gets run with DT, and the DT gets calculated based off of the time since the frame start, where frame start. Oh, it's time.now. It gets set here. Right, so we calculate the delta, and then we calculate the new frame start. And then we can scale, we do some some game speed scaling, but this shouldn't actually, this should be set to 1. Yeah. Scale DT, accumulator plus equals time duration, scale DT. This should be 1 times the nanoseconds, and then we make a time duration based off of that, and we add it to the accumulator, and then the accumulator kind of builds up constantly until it goes above the fixed time step. It becomes equal to or above the fixed time step, and then we loop through all the physics systems, and we execute those one by one, running them with the fixed time step. And then when we run one, once we finish running all of the systems, we subtract out the fixed time step. Is that correct? Let's see. I guess let's just write a test file here. This is in our ECS package, by the way. All right, let me do this. Let me copy a little bit more. Okay. Func test sched. Actually, does it need to start with test? Yeah. Okay, what we can do is basically, I basically just want to make sure that this runs at the right time. So we're going to do schedule as a new scheduler. That'll make a new scheduler with all the defaults. I think the default is 16 milliseconds. Yeah. Which is fine, because that's what we're using in our game. But I think it's good to explicitly set this stuff sometimes. That way you know exactly what it is all the time. And then I'm gonna do scheduler.append. We're gonna do a test scheduler physics. Append. This is appending physics systems. Now I can just lump on a bunch of systems. System. I'm just gonna add 1, I think. I'm gonna add 1 with a sleep in it, I think. And a system, all it has is a name, test system. And this is just so that can be printed out later on. I want to eventually make it so that this comes from some reflected value of the name. But one day. One day. But it's not that hard to type it out anyways, so. Okay. So we're gonna format.print line, and what we're gonna print, actually let's do printf. We're gonna print the DT, which should be 16 milliseconds. And then we're also gonna print We'll save that and we'll do time since time.since last time. This is kind of what we're doing on the server. So this will check that we basically want this to be very close to this. Excuse me. And then we'll do last time is equal to time.now. We obviously need to import the time package now. No problem. And then we'll do a print out, end it with a /n, %t, %t. Okay. Now we need to do, oh, I always do this. I should just call it scheduler. Because I think my natural tendency is to use that. Scheduler dot run. I think I need to make a quit signal too. I guess this can just be this because it'll default to false. Pass the quit signal in. It's basically just a thread safe bool. I guess I could have used a what's it called? I could have used just an atomic, I think, which maybe I will switch it to that, but actually let's try it to do. Okay, then we'll run this in the background, and then I'm gonna do time.sleep, and I'll just do like 1 times time.second. So we'll run it for a second, and then we're gonna quit. We'll set quit to true, and then that should quit it, and we should be done. Good morning, JJ. How are you doing today? Okay, printf has %t. I thought %t was, let's do %v. I think that figures it out for me. Doing okay? How are you? I'm also doing okay. Perfect. So this one's messed up just because the default is 0, so that's a big delta. This is what we want to see though. So this is the same behavior we're seeing on the server. So that means I'm running it like too slow. Let's figure out why that is happening. Now that we have a test that replicates our problem. I wish I had a way. I should build an Emacs command that switches my 2 buffers. I feel like I constantly want to do that. Like I want to work on this buffer always for some reason. I always want to work on the right one. But also, ever since I got these cats, like the only time I can work is when I stand at my desk. So like I just stand almost all day long now, which gets a little, it gets a little tiring to be honest, but it's okay. It's not bad. I still enjoy it. Excuse me. Okay, what were we doing? Oh yeah, we're looking at this fixed time. Let's try another one. I'm gonna make a physics system. I'm gonna make an input system. Append input, test system input, test system physics. I envy your ability to just not have a job for a solid year. Oh, it's very nice. But I've been saving a while for this, so. But obviously not everybody can do this. So I'm very grateful that I have the opportunity to try. Last time physics. Last time render. How long did you save for? I reckon I'll be able to save up a year's worth of current input in like, current income in like 3 years. Got high rent and shit. Yeah. Yeah, rent is like the biggest rent's my biggest expense by a long shot. So I think reducing your rent as much as possible is like the best way to like save money. Um I guess I've been working for, when did I get my first job? Like professionally as a software engineer, I've probably been working for, oh geez, I don't know, like 8 years maybe. I've been saving for like 8 years probably. But like I always had a job, like when I was in high school and stuff like that. So I would save then. What's up, Jacob? You're no longer a slave to corporate Java? I am no longer, no. I guess it's been about almost 3 months now, which is actually like crazy to say. I feel like I haven't done as much as I wanted to get done in 3 months, but here we are. Gonna live in a van somewhere at this rate. Hey, that's one way to do it for sure. Yeah, thank you. Yep, quit my job. You're not living a good life and I'm depressed and not succeeding. No, you're good, dude. You just gotta apply for those jobs. I feel like you're too concerned about how you're gonna eventually get the job you want when you should be concerned with just getting any job. I think you'll find that you do better than you think you will. We need game releases soon. I know that's the thing. That the making games takes a lot of effort. So, but I enjoy it. I enjoy programming in general. That was the problem I had with working the corporate life, is that I hope it's remote. Yeah, those are a little bit harder to find nowadays, I think, now that COVID's kind of dipped a little bit. That was the problem I had with the corporate life. Like I would have enjoyed the corporate life if it was more like what I'm doing now, where I can just like build whatever I want. But I guess you have to give up some of that pay to work on the stuff you're really interested in. But yeah, thank you. I'm very excited. We'll see how the next couple of years go. Hopefully I'll be profitable at some point. But my expenses are very, very low, so I don't need to make too much. I just need just enough to skate by. So yeah, it's all about growth right now. Let's make our own corporation where we just hire people to invent shit. That sounds pretty good. The problem is I don't have money to hire people. I don't have like that much money. I have enough money to like do a couple years of just me working and not making any money. But what's up, Michael? How you doing today? What did I miss? Uh-oh. We are trying to, well, I guess I can go through it really quick. The problem we were having is we're trying to smooth out. We have a bunch of network packets come over at one section. They're kind of chunked together like this. So when you interpolate that, it looks kind of choppy. Like you move, stop, move, stop, move. What we try to do is we try to enqueue it and then dequeue it at a regular interval of like 16 or 32 milliseconds. And that kind of smooths out our interpolation that we play back, but it adds some delay in. Then I was looking at, like, that's what I've built, but it's still not working. Everyone's saying congrats in chat. What happened? I quit my job like 3 months ago. So 1 profit, 2 question mark, 3 move to Thailand. Yeah. I actually had a guy I worked with. He was like really into Bitcoin right when the very first spike happened. So he's like really invested in Bitcoin, and he's just watching it every single day. And we were on like a field deployment together, but he wasn't at the same company. He was at a different company. And he, like, Bitcoin hit its peak, and he was just like, he just did not come back the next day. He just quit like on the spot and moved to Thailand, I think. So it's kind of an interesting, like, you can do that if you make it big somehow, you know? But when I was testing my systems out, I'm finding that I wrote a little unit test. Yeah, it's gonna do a lot of printing. I didn't think about that. Watch me crash my computer. Love it. Can't wait. Uh-oh. It's not letting me kill it. Kill? Let me do this. Okay, there we go. Whew. Smart guy, yeah. Hey, yeah, he definitely did it. Unit test go Burr. Yeah, the problem is all I'm doing in this test is I'm just printing a bunch of stuff out, and these ones gonna run as fast as humanly possible, you know. So unit tests do go Burr. Okay, let me comment. I actually do want to look at this, don't I? I'm gonna do time.sleep in both of these. I'm just gonna sleep in them. I'm gonna make this 10. All right, there we go. Starting my day at work, nice. Another day, another $1. Changing decorations out for Christmas ones, nice. Dory's doing some homework. Homework assignment? You better not be procrastinating. Okay. That's interesting. When I have these systems in place, this is way less consistent. Look at that. Well, now it runs in 11. Did I might have messed this up. Last time in physics, render, physics, input, physics, render. Okay. So that when I don't have these systems in place, it seems like it runs at this time. I guess it's okay if it goes above. It's strange to me that it goes below though. Oh, I guess it accumulates up. What's 11? Yeah, 11 plus 22 is approximately 11 plus 22 is what? 33. So that kind of averages to running at 32, I guess. I'm trying to think of how this works. These ones run as fast as possible, which is good. Let me do this. Okay. I should align these, huh? That's gonna be hard to read. Let's see. One for that. And physics is one character longer than render, I guess. Yeah. So space here, a lot of space here. Okay. We're nicely aligned. Input render, input physics render. So if we like mentally think about how the accumulation happens, this adds 11 seconds. Or these two add 11 seconds, and then we get 11 more seconds added. So it's like 11 seconds. It's added at the end. So this should add, this should be like 22. Oh, but the physics one doesn't know that because he doesn't know his initial time. I guess I could do this. Let me do this actually. Do that equals time.now. Okay. Okay. So these ones have basically no startup costs. That should add 11. That should add 11 milliseconds DT. I don't know what this adds though. I guess this probably adds 11 as well. I don't know. But then physics is able to run, but it's 23, which I guess is pretty close to 11 plus 11. You know? But it should be only running 16. And then you do one more. Let's see here. Then you do one more 11. 23 minus 16 is what? Sorry. I just can't do math while I'm thinking about other stuff. 7. So we have 7 plus 11. That makes us 18. And then we run again, which would put us at 2. Nope, I wanted this to be 2. Okay. Okay. 2. We were here. Then we run again for 11. Plus 11. Which is 13, which isn't enough. Then we do 11 again. That gives us 24. Then the physics system runs. So that part's working. But it only works when, it seems like it's working here when the other systems exist, but it's not working here. So I just need to look at system. That's our clue. Give me 1 second, I have to cough. All right. It is weird though. Let's see. So if there's no input, this is basically empty. This won't run. This also won't run because there's no render. Which means that the DT calculated is going to be very close. It's gonna be very close. Because the only thing that's happening is this physics system every once in a while. When the physics system is not running, the only thing that's happening is this. So this is gonna be a very low number. So this is gonna run an enormous amount of times. I think what I do is I almost want to change this logic to if I have a fixed, if I have only the physics system, instead of looping, like I can, let me do a printout here. DT, like this is just gonna keep going, you know? Maybe I'll do this in a terminal. Workplace, let's see, ECS, go test dash V. No format, okay, we can fix that. In Emacs, it's harder to kill stuff. Yeah, do you see all these printouts? Oops. Let me do this really quickly. I work in fintech. I don't do much low level stuff. Sounds very fun. That does sound kind of cool. I've never worked in fintech before. Credit reporting and credit building. Interesting. Use credit bureaus inherently create convoluted systems so individuals are not able to accurately calculate credit scores on their own. It's all kind of crap. They lobbied for that. Yeah. Lobbying is such a weird thing because on one hand, it's like it does make sense that corporations do have some interest in the laws that get passed, you know? But on the other hand, like they can definitely abuse that power because they have so much money. Yeah, I agree with the tax part. It's like, I don't know why the government doesn't already just know what my taxes are, you know? How's Florida? It was a little bit cool out this morning, but I think it's going to heat up in the afternoon. But I'll mostly be inside, so it's not too big of a deal for me. But it's a nice average day. We're in like the 80s though. It's not cold. Or I think right now it's in like the 70s, but I think it's going to get to the 80s. Unless you're European, in which case it's a whole different ball game. Here it's freaking cold. Yeah. So these are very, very low numbers, right? 773 nanoseconds, 1 microsecond. And this eventually builds up. Okay, that's why we're seeing that. Yeah, that looks all cleaner now. I think this is going to get truncated probably. Yeah, so there's a ton of loops happening here, which is kind of a waste of energy, right? What I think I might do is I might have an edge case here where if you're only a fixed time system and you have nothing that happens dynamically like this, I think what I'll have it have happen is I can either do the same loop, which I probably will. What I'm thinking is I'll have like a actually, maybe what I should do is sleep. No, we can't sleep. We can't sleep in all cases until the next tick runs, right? Because we have these dynamic time systems, which shouldn't have that happen. So if both of these are null, or sorry, if both of these are empty, then we can sleep. And we can accurately kind of predict our sleep too. And what we'll sleep for is the remaining amount that the accumulator needs to add before it we'll go above our fixed time step. For with only fixed time steps. Let's see here. If s.render, actually, are these default to null or? Yeah, I make them regardless. Okay. I'm gonna be a little bit OCD and put render after input. if the length of the input systems is 0 and the length of the render systems is 0, then we know we're only fixed time steps. So if we were only fixed time step, what we can do is we can say, because the accumulator is constantly building up value, building up like charge almost, and then it gets discharged once it passes this fixed time step number. So if we want to kind of guesstimate how long it should wait, we basically just want to wait. We want to sleep for the remainder. Sorry, not the remainder, but the fixed time step, which is what we're trying to get to, minus what the accumulator value currently is. So we have a fixed time step, which is going to be like 16. Let's say this is at like 5. Then this is going to calculate 11. And then we're going to sleep for 11, basically. Sorry, I don't have the character pack. So I don't know those words, unfortunately. Unfortunately, I need to get some more font packs. I've been berated before. It's my bad. Okay, that sounds pretty good. Fixed time step is a time duration. This is a time duration, so this should be a time duration as well. This should work. Get the fonts. Get all the fonts. Look at that. Look at that beauty. There we go. That's really good. That's good enough, I'll say. Interesting here, it goes below. I guess because the accumulator kind of builds up a little bit. And then it can go a little bit faster for 1 tick. But the average is now 16 milliseconds, which is good. Okay, let's go back to our run. Okay. Now we're talking though. Look at this. 64, 16 every time. Love it. Queue fills up though. That's a different problem. This is probably like the root cause of all of my struggle yesterday. And this is why you write unit tests, kids. This is why. Don't just trust yourself. I still don't know why. I still don't know why this didn't work. Like why my original code didn't work. Did I hear that right? Yes. If what you heard was never write unit test, testing what that? I don't know. I just read a book about it. I do test my code, I just test it manually. I genuinely don't know what happens here. Like this should just be incrementing until it hits 16. Then it should be bigger and it should just decrease. So I don't know why this, I wonder if it's something to do with this, like multiplier gets a little messed up. Like multiplied by 1, it gets, I don't know. Because this was incrementing, this was increasing. I don't know. I don't know. I don't know if it's worth knowing. I'm genuinely confused though. My users tested for me. I love that. Same. That's how you get a bunch of GitHub tickets. Have I changed? I've grown. I've grown as a person. I am. I'm improving. I'm getting better every day. Look at that smooth interpolation though. Everything is covered by an end-to-end test. It just happens to be manual and taking place in production by our users. Exactly. See, I don't know why I'd spend my effort testing when my users can just test for me. They'll let me know if anything goes wrong, right? Oh. Okay. Well, I can't get syntax highlighting working for Crystal, but I just set the language to Ruby, so 90% of it should be correctly highlighted now. Oh, that's smart. I've done that before. Whenever I have to code shader stuff, I don't have a plug or I don't have a syntax highlighter for shaders, but it's similar to C, so I just write I just change it to C mode in Emacs. It looks pretty good most of the time. Most of the time. Okay, let's go to client now, client 2, which is a terrible name for a file. But okay. Actually, let's look at the okay, let's look at these. Server send update last time. These are all 16. Then it sends a big one, or actually sends a tick. These ones are just the fixed time step happening. Then we send a tick. We get a network tick. We pull the network tick. We have a delay of 3. Interp with time 64. And that should be about right. So this should line up perfectly. And it looks, all right, let's do this actually. We'll search for this because this is every time the server sends. Okay. Send, we got one. Or pull, send. We got one. We didn't pull it till here though. Oh, this might be where I need to add back. We want to subtract out. Because we're subtracting out DT everywhere, we want to subtract it out here because we're about to run it once. So we want to add one more. Like we want to apply this subtraction that we would normally have applied. Wow, look at this perfection. Oh, it's growing a little bit. I need to have a check if the queue gets too big. Um, but the interpolation looks really nice. That's the important part. Let's do this. I'm gonna make this queue length like 100. It's kind of weird that it starts so far behind though. So I need to have some kind of catch up. Because it's running at about the right speed. The interpolation looks perfect though. He's just drifting backwards ever so slightly. This is kind of cool. Oh, let's add some big delay. Lag. If that ain't smooth, I don't know what is. Our buffer is actually absolutely massive though. So you can even see when we drop packets, we just double the distance between the two. Like we kind of fake out that there's an extra tick there, and we increase the time it takes to interpolate. Are most folks in the chat in Discord low level developer people? I think most people are pretty high level, except for, I'm trying to think. I think people have done some, I don't remember. I don't think anybody's really done that much low level stuff that I know of. Small brain TypeScript and Go developer here. So I need to have some kind of catch up, and what that catch up is going to look like is it's going to look something like if we get too far from our target tick, we'll just decrease our time a little bit. And I literally think I can decrease it by like 1 millisecond, and it'll probably get faster. Let's reduce this back to 10. And we're going to make our target tick is 3. So what we want to have happen now. What's up, Ren? How you doing today? You see the interpolation is finally working a little bit better. The stuff Unit is doing blows my mind. I was a low level, I was actually an electrical engineer in college. So it transitioned. So I grew up writing like C and C++, you know, or mostly C++, and then I learned C in college, and then and I did like a lot of like computer architecture type stuff too. Some VHDL, some things like that. Built some PCBs, and kind of learned programming along the way. Did a little bit of assembly even. Then I failed out and became an accountant. Haha. Nice. Nothing wrong with that. Everybody's got their strengths. Fintech sounds like an interesting area to go into. I want to try out performance of different languages for a server as my next project. That'd be interesting. Network and distributed engineer here in Go C++. Yeah, I'm very interested in distributed systems, as you can tell. Hence the YouTube channel about it all. But it's funny because most of the time I spend is like, not most of the time. A lot of the time I spend though is writing like OpenGL and stuff that I'm not super interested in. But, you know, what can you do? But I'm interested in like network physics simulations right now. I think those are pretty cool. Finally got the emojis. Nice. Good old face red droopy eyes emoji. Do you guys see this? The naming on this stuff? Face red droopy eyes. I wish they just named this stuff better. The problem is what they should have done was they should have taken memes rather than try to make their own. I guess we'll see how it turns out, but they're not bad. They're just a little they're a little heartless. API developer and Go, nice. I think Go's a good language for APIs and distributed systems in general. I think Rust is the only other good contender. Let's see here. Oh yeah, I was gonna slow down. Where am I? I have so much commented code. These are all my different attempts. It's bad. I'm a lot happier today now that I've like kind of solved this a little bit, you know? It makes it a lot more fun to do work when I'm not like banging my head against the wall. It's a little awkward to like stream and just be like, I have no idea why this isn't working. I'm glad we finally figured it out. Yeah, you're right, Jacob. It's a lot of spaghetti out here. I do love Italian though. Okay. So we'll do an else if. So if we're greater than the target delay, Recently used the XP experimental screen package in Go just to visualize some distributed algorithm. It's annoying when the visualization takes longer than the actual logic. I don't know that package. EXP screen. You want high latency built into your systems? TypeScript is also a good alternative for APIs. Nice. Yeah, I'm kind of I'm impressed that JavaScript made such a big impact for APIs. Is this the package you're talking about? Oh, XP Shiny. Screens are not created directly. Instead, the driver package provides access. This is it. Screen buffer, texture, and window implementations that work together. What is it though? A portable two-dimensional graphics? Such as X11, but other drivers such as OpenGL driver can be explicitly invoked by calling that driver's main function. New window. Each driver provides screen, buffer, texture, and window implementations that work together. This is the top level interface, I guess. Such types are interface types because this package is driver independent, but those interfaces aren't expected to be implemented outside the drivers. For example, a driver's window implementation will generally work only with that driver's buffer implementation, will not work with arbitrary types. Okay, that makes sense. Buffer release. Oh. Size, image.point. There's some examples in the source. Is this like, is it a windowing interface? Event DQ. Is this for building like UIs? Isn't that what Shiny is? Get title, screen, texture. Yeah, let's go to the source. Makes a UI interesting. Shiny. Example. Let's see here. Okay, GL driver. Oh, I wonder if new triangle GL widget. So I can use OpenGL with this. Flex widget, color patch with layout data. Is this fast? Like, is this using OpenGL? Could I use this for my game or no? Load shader. GLCTX, what is that? Oh, you create a program. Where's GL come from? What GL is it? Mobile GL. The GL driver is OpenGL under the hood. Interesting. I'll have to look into this. I had never heard of this. But it would be nice if there was some package. The XLL driver is terrible performance. What is XLL? Oh, it's a golf driver, I guess. But like it seems like you can make shaders. Get program I. Oh, X11. Oh, so this is just gonna run slowly because of the X11 driver. Does it use? I don't know X11. Triangle data. Interesting. OpenGL driver is faster. Yeah, that makes sense. Screen widget. I wonder if this would be a good, I'm curious now if there's any big performance overhead of using this. Because I would love, is the normal window driver for Linux? Oh, okay. I guess I'm not really sure. I guess I don't really fully understand what X11 is, but like when I use GLFW, doesn't that use X11? But I guess when you use X11, you don't use OpenGL, you end up not using the hardware to do your rendering. You end up using like the software image rendering, which is probably the slow part. Layout. I'll have to, I want to look at this later. Oh, I see, okay. Because I would like something like this, because like Rust has that web GPU package, you know? So it'd be nice to have something like this where you have a bunch of drivers that implement the same interface and you just build all of your rendering on top of that. I would like that a lot. Obviously, this would have to like be very well done, but I need to check if you're running Wayland. I think I'm doing X11. Oh, Plasma defaults to it. Oh, I might be then. Maybe I need a Wayland driver. This is interesting. I'll star this. I'll have to look at that later. Whales? This? Oh, beautiful cross-platform apps using Go. This is like a UI thing, right? Can I get like a OpenGL context in here? The traditional method of providing web interfaces to Go programs is built in web browser. Rails offers a different approach. It provides the ability to wrap both Go code and web frontend into a single binary. Tools are provided to make this easy for you, handling project creation, compilation, and bundling. All you have to do is get creative. Interesting. It does sound like an Electron. Use WebGL and Whales. Gotcha. Who's this project aimed at? Go programmers want to bundle HTML, JS, CSS front end with their applications without resorting to creating a server and opening a browser to view it. I like the hand drawn. Let me try that. I'm gonna do that on a different screen now. I don't know what it prints. I will copy that though. Oh, look at that. X11. I guess that was X11 after all. Because I remember when I was installing something, I didn't have the Wayland version. I got the X11 version. I know Wayland's like the newer one, right? I'll have to start this too. I'll take a peek at these. I don't think Whales is exactly what I would want though, because I want to use the hardware OpenGL. I don't want to use WebGL for the desktop app. It would be nice to have like one, and that's kind of what my GL and GLFW packages do. They kind of abstract away the hardware a little bit, but it would be nice to have like a production ready one that someone else has built. Okay, back to this though. If our buffer length is getting too long, we want to shorten our total WebGL is hardware. Yeah, I just think that, well, I assume that using WebGL inside of Whales is going to be slower than using native OpenGL. Because there's going to, how Go interacts with WebGL is it has to go through this JavaScript interface, which requires a lot of like buffer copies and stuff like that. Because you have to copy the memory to JavaScript before you can upload your like vertex buffers and stuff like that. So then, yeah, so that's where the slow part would come from. I assume like once you have the data over there, it probably runs like pretty close, but just getting the data to JavaScript land is a little bit slower. But maybe one day they'll have like native WebAssembly that calls WebGL instead of having to use the JavaScript bindings, but I don't know. I'm not super familiar with that stuff, but that's how I understand it at least. I'm just gonna subtract out one more tick, which might actually cause a little bit of a hitch. I'm just curious what this looks like. Yeah, so I'm now causing hitches because I'm getting a little bit too slow. It's also interesting, my send rate is a lot faster now because my my server is running at the right speed now, which is kind of interesting. Man, I wish I looked into that. I even suspected something like that was happening, but I didn't really investigate it. I should have tested that better. I don't know how to slow this down. I need to slow down ever so slightly though. Should be printing too long a bunch. One times time dot millisecond. Let's just subtract 1 millisecond and see what happens. I think one problem I'm having is I'm measuring the length of the queue. I'm not measuring the delta between the ticks in the queue. And by that I mean like this is like tick 1, that's tick 2, 3, 4, and let's say 5's over here. If my queue looks like this, 1, 2, 3, 4, let's say 5. Let's say 5 gets dropped and we just have 6, 7. I'm able to like because I know that there should have been a 5 in here. Like if my current queue looks like this, if I measure the length of that queue, it says 2, but in reality, I kind of already know that there's a 5 implicitly in here, and I do account for that already. So this measurement is wrong. And that might be why some of that speed up is happening. Or so like even though it says that we're only 1 tick difference, well, actually, whenever you see these, a delta tick 2, that means that we missed a tick. So a tick got dropped. So in those situations, it would speed up. So let's fix that, I guess. So when I call length, I actually need to calculate. I'm gonna change this to do delay. So now we need to build a delay function. That's basically gonna just use the first tick, last tick. Wait a second. Oh, that's right. Okay. First index, last index. Because I write to where. Yeah, I'm reading from where it is. When I do a write, I add afterwards, and when I do a peek, I just read this spot. Okay. So this will be the first index. That'll be the last index. I don't need to do this, or I shouldn't do that rather. What I want to subtract though is I want to do. I'll just do. I'll make it clear. First is this. Oops. Last. So we want to do last minus first. And this will be the delay in ticks that we currently have. That should account for those. That should account for the. What do you call it? Those like dropped packets. Oh, I'm doing the wrong thing. It's server tick. Yeah. Oh. I'll just convert it to an int. Ints are generally easier to use. Too long. There's a lot of too longs. Oh, delay is being calculated wrong. Delay. Serve. Last dot server tick minus first dot server tick. What am I doing? First and last. So last minus first should be 1. I'm trying to think here. Why is this happening? 55, 43. Oh, wait a second. Actually, no, that's kind of okay, I think. First is 55, last is 43. Why is it less though? Hmm. So we're subtracting the wrong order. Or no? $43, 43, which is 0. I'll just go in the middle somewhere. These are all zeros. What the heck? I guess I want to do if length. $69, 62. So it's really first minus last. I don't understand why that is, but I've done some confusing naming conventions here. Looks like a delta tick. Okay, these are mostly 1 now. That's so strange. Oh, that must have just been too early on. $72, 62. That's so weird. Oh, okay. Then delay gets calculated as 10, which is actually correct. Delta tick. Oh, that's how we're interpolating. Yeah, okay. And this is correct, I think. Next t dot delay. Do I use length here anywhere? Okay. Let's remove this altogether. I just want to see what it looks like. Looking good, figuring out errors. Nice. Sure am. It is still growing. And because it's growing, like delay should just be, oh wait. That is strange. It seems like it catches up a little bit. I wonder if it stabilizes. Doesn't seem like it does. Like it seems like it just gets longer and longer and longer and longer. Like there. That's what she said, yes. Yes, indeed. Welcome, homeless duck, to the stream. That's a solid intro message. I like it. I genuinely had to think about that. I was like, what did I just say? Because no, you're good. I like it. It was funny. But when you said that, I was like, what did I just say? I hope I didn't say anything too too suggestive. That was a good one. She would say that. Not to me, but to someone else, probably. You need to process each event. If there's no delta between two events, constant velocity, could you ignore that event and use the most recent one? Ayo. Yep. Hold on, let me reread that, Jacob. Do you need to process each event? If there's no delta between two events, constant velocity. Yeah, so the problem with like if I think I understand you right, what you're saying is like we have hold on. Use the most recent event. So you're saying like you were saying like I'm here. So I'm gonna draw a red line on top of this. So instead of like right now I'm interpolating 1 to 2, 2 to 3, 3 to 4, and then I wait until the next one comes in. But you're saying that I like move to 4. I move straight, or like I guess this would be kind of the same. As these come in, I just go to the next one. And then like once these 3 come in a batch, I guess I have to wait here. And then I just interpolate to this one. I don't know. If there's no delta between two events, like a constant velocity, could you ignore that event and use the most recent one? I think the general problem with interpolating to the latest one, I think, is that it means I'm going to like eventually experience hitching. Like once I get there, if the next packet doesn't arrive in time, then I'm gonna have to pause. I don't know if that makes sense. Like the reason that I have to replay them is, and I need to replay them at the fixed length, is that I want it to come out very smoothly. Like they're coming in very haphazardly, like they're coming in clusters usually, because there's jitter. There's like TCP retries, things like that. And then when I pull them out of the queue, so they're getting stuffed in at kind of like random times. And then when I pull them out, I want to pull them out individually, one at a time. Unless I might be misunderstanding what you're saying. So you could debounce the incoming events. I might need to write this out. I might need to write this out in a larger post. Yeah, maybe so. Are you saying like I still have the buffer, but like but I always read it to 0? I always read to the last one? Like the problem is if I always read to the last one, like if I in-queue everything and that's kind of like debouncing it. No, not really. Okay. Sorry, I don't think I understand. I might need a blog post. Originally what I did at the start though is I had no queue and I would just interpolate from where I was. Like and then let's say I got a bunch of new positions. Boom, boom, boom. I would just interpolate you there. And then like if a new one comes in, let's say the new position comes in there, and by that time you moved over here, I would interpolate you here. And the red is you, and then the green is where the server just said you were. Is that what you're saying? Uh-oh. This must be a long When entering over the events in the chunk, we could preemptively drop events where there's no delta. Oh, in terms of position? Like for example, you're here, and you just haven't moved anywhere. So the server's just saying, you're here, you're here, you're here. And there's like 3 of them. And then you start moving. Then it's like, oh, you're here, you're here, you're here. Even in velocity. Oh, so this is more like um if you haven't changed your velocity, the server doesn't have to tell the client that the velocity is the same, basically. Like there's no reason for the server to tell the client that this entity has changed its velocity. Gotcha. Yeah. No, that's definitely an optimization that we can do. Um, I don't operate on velocities. Like when your key is down, I just move you. I guess I don't really have like a velocity component that's on things. So it's more like if the input changes. But this would be useful for entities that aren't me. Like for my entity, I know what my velocity is at all times because I'm the client. I'm the one that's producing the velocity with my inputs, you know? So like my inputs are controlled. My inputs on the server are controlled by me. It's a good talk. Oh, a Rocket League does network physics with preemptive lag correction. Oh, that's interesting. I'll definitely look for that. I don't think I've seen that one. I saw one for Overwatch, and that was really good. But Rocket League is a much more challenging simulation, I think. Almost all games do predictions client side with velocities. Yeah. Yeah, like I do have client side prediction based off of my inputs. And I basically replay the buffer. So I basically track a buffer that's like the server said you were here. And in that time, you did all of these inputs. And that moved you to like over here. Like that's how your input changed your position from this thing. So I put you over here instead. And then over here, the buffer's a little bit smaller maybe. Because you got like 2 ticks at the same time or something like that. Then it's like, actually, the server said you were a little bit further down. So then you end up over here or something like that. So I have like the server interpolation, and then I have some client replay that I do to re-establish where you should be. And that makes things a little bit more snappy. But it's an extrapolation. I talked about this a little bit yesterday. I don't remember. It was here. Yeah, I was talking about how you can either interpolate or you can extrapolate. But you basically push these into a buffer. An extrapolation lets you be a little bit more snappy, but it's not as like perfect. Like interpolation is perfect because you're interpolating from where the server said you were to where the server next told you were, so you can interpolate that. And the buffering is just for smoothing. And extrapolation is like you can also add in a little bit of like client input to put you somewhere else that the server hasn't. This is input that the server hasn't factored into your position, but as input you know that or you hope that the server will factor in eventually. Usually that's backwards of how you described. What do you mean? Sorry, which part's backwards? Oh, like they don't this part's backwards? For instance, Overwatch, since you mentioned it, the server just validates where you are. The server just validates where you are and trusts the client to make decisions, then adjusts only when needed. Oh, that's interesting. I guess puts a lot less pressure on the servers. I'm trying to think of how that would work. I'm gonna write a blog post. All right, I'll read it. I think I'm doing, like, the server still has to do all of the same computations. Yeah, I guess it depends on what you mean when you say entrust the clients to make the decisions. Like if I know they have a bunch of anti-cheat stuff in first-person shooters because they want to client as a source of truth, just rely on calculations until they are wrong. Yeah, so I would need to if I wanted to do something like that, and I'd want it to be like more cheat-proof, I'd have to use some sort of anti-cheat thing. I was hoping not to do that though, but yeah, that would put less pressure on servers, but because then it's like the client just determines like, yes, I hit somebody, and then the server has to be like, okay, yeah, I guess you hit them. Yeah, so you can do some of that. Like the client gave me something that's impossible, but it would be hard to, like, let's say you're playing Overwatch and you're aimbotting. You know, it would be harder to detect that. It's like, did he just aim really well, or is he cheating? Because the client just said, "Oh, I hit this guy." But yeah, you could do some, yeah, so like some heuristics which do like, oh, he couldn't have possibly moved that far. Projectiles is a bit different. Yeah, maybe there's some interesting balance, but I'm doing how I designed this was to be server side authoritative. So the server determines where everything is, and then I just try to compensate for lag as best I can. I think what I'm trying to say is if the client always sends events, but the server can drop events that don't cause any perceived delta, and the client only receives the delta events. Yeah, the tricky part of that, I think that's a reasonable approach to I think that's a reasonable approach. Well, I haven't thought too much about that, but doesn't cause any perceived delta. There is some challenge there, I think. I'm not really sure how to like explain this, so I'll try my best. But if you're gonna do delta, like I think what you're describing is like kind of only sending clients in the event that there was some delta, and the one challenge I think that exists there is now the server has to track the state of things. Like the server has to know when a delta event does happen, depending on which client he's talking to. So you almost have like you might have to know the server might have to have some knowledge about what state each client is in terms of what they know about the world. Like if you walk into a new zone, let's say you walk into a new zone and there's like people that were already there. Like there's probably some way around it. I'm just thinking that there has to be some additional like synchronization thing, if that makes sense. But there is I think the term of what you're calling is called, well, part of it, or there's something called delta encoding, which is about compressing data based off of the deltas of previous and using the same queue for all clients. Currently I am, eventually it'll be more client specific. Just the challenge I think is knowing what each client knows. And I'm hoping not to get too into that logic. I'd prefer for the server to not know that much information about the state of all clients. But there might be some interesting optimizations that are possible there. But like, I think how I'm going to end up doing it is there's going to, because like eventually there's going to be like, let's say there's eventually there's going to be a queue of all the data that needs to go to a specific client. Let's call this client A. Then we'll call this client B. Then we'll call this client C. And maybe this is Bungie has some good blog posts about how to do some client sync stuff. Yeah, gotcha. I'll also look for that too. There's a lot of interesting networking stuff out there. But eventually I'm gonna have like some sort of priority queue of like, there's some update that needs to be sent to all of these guys. And depending on like how relevant it is to each client, it'll either have a higher priority or a lower priority. Like for example, let's say this is like update A. Like this is an update for the A's player, you know, like where their person is. Like that's a very important update. So that's gonna go to the front of the queue. This would be like update B. This would be update C. So like that sort of update is a very important one. But then like the update for A that we send to B isn't as important, so it can go further back in the queue. Same with update C. And then maybe there's like some monster or something like that that needs to be updated. Like that actually might be a little bit more important than updating other players if it's a PvE game. It just depends on how important each update is. So I'll probably do some sort of prioritization and a queue, some priority queue for each client and track things that way. I don't know if this makes sense, but I think logically I hope it makes sense. But so then if like what I could conceivably see happen is if this value hasn't changed at all, if this value is the same, then there's probably not a it's not a very high priority thing to update. So it has a probably a lower priority. Sorting queue equals mutex per client equals bad performance. I'll probably use a priority buffer, like on a heap. I don't think it'll be too bad of performance. I think the bandwidth improvements will be worth it though. It's good, and each queue. I guess I don't know what you mean by mutex per client, because each of these could be in its own. I could do all of this sorting each on its own thread. I think. I haven't thought about this too much though. But I don't think that the I don't know. I guess we'll have to write it and then test, see how bad it does. I don't think this is going to be the biggest performance suck though. I think collision probably would be. You want to sort by priority for each client. It means you have to lock when you sort, hence MX per client. You have to lock when you sort. Oh, it's not one queue. This is 3 separate queues. I think that's what you mean. You're saying if there's a bunch of updates and there's one queue, then when I send to A, I need to resort it to send to A. And then I need to resort it to send to B. But this is going to be like a priority queue. So I'm going to push updates onto this and deduplicate them as needed. So each A, B, and C is going to have its own queue. So then when I send to A, I'll be like, if I did sort it without using a priority queue, I would just sort it once and I'd leave it in that state. So then it's mostly sorted, except when I push new stuff in, maybe I resort it. That'd probably be like the naive way of doing it, which honestly I might do to start off with, but this will probably be my strategy, at least to start. Once I start regionalizing, this will be like probably, actually this might be a next kind of network optimization I might need to work on next after I get this guy done. I'll have to look for the Bungie post though. I've done a lot of reading about this sort of stuff, but I definitely have missed some things. And obviously when it comes down to like coding it, it's always like, oh, well, actually, I don't think that their solution applies super perfectly to me because they're building different kinds of games. What was I doing? We went on a tangent there, didn't we? What was I doing? I guess let's run it. I genuinely do not remember. Oh, that's right. So when we get too far away from our destination tick, or the tick we want to be at, we need to slow. Oh, I commented this out. Too short, too long. I was slowing this down by 1 millisecond. I don't know if that actually helps. It seems like it's still going too fast. Maybe this is too short. This makes it longer. If the delay between ticks is too short, then we want to make the ticks longer. So that slows down the movement. Delta ticks. Oh, so this is technically, I'm gonna change this to be next T. So I'm gonna make it twice as long. That's what this will effectively do. There's how long it should normally interpolate for. I'm gonna make it twice as long, and that's gonna hopefully extend it. I think this was too short, and that's why it was going too far down. It's still going a little bit too fast, but I'd avoid sorting. I'd have different priority queues altogether, and the reader for each one will simply distribute to clients by their ID instead of each client having their own queue. I'd have different priority queues altogether. The problem is the priority is based off of the client. I could maybe batch clients together to reduce the number of queues I have, like similar clients. But like the priority of the queue is specific to each client. So that's why I was thinking I'd have to have them per client. But we'll have to see how the performance is. I don't think I don't know. I don't think the data set's going to be like so massive that I feel like there'll be other obvious ways to improve it other than like I just don't really know of a good alternative. The reader for each one. Yeah, I could maybe have some like regionalized priority queue. Like in this region, here's the priority queue. But that might end up being yeah, I don't know. That might end up, I'm trying to think of how that works. I guess that could work. If I have like a small region which has its own priority queue and all of the updates get kind of like normalized for that region and sent to all the clients. And then per region you have, if you have 1,000 clients in one region, you have the same 1,000 or all 1,000 of those clients get the same update. That could work. The movement is high priority, but turning is not. You process high priority queue, then lesser priority queue, then lesser back to high priority. Yeah, I get that part. But we'll have to see. We're not doing that today. We'll do that another day. Another day will be priority queue day. I could see it being regionalized though. And sending the same regionalized update per region. I think that's pretty rational. That could be a good optimization. I think the general principle will be very similar though. You wouldn't be able to do some of this special stuff though. Where like making sure user A, like the problem with regionalizing it is if you have a lot of things coming in, person A might not get their update for themselves. I could maybe just always tack them on because that's a very high priority update. You always want to get your update, but everything else can be a little bit slower. So maybe I just tack on their update with whatever comes out of the normal queue. I don't know, we'll have to see. All right. I'm gonna comment this out really quickly. I'm just curious if this slows down. Yeah, okay, that slows down quite a lot. Maybe I just do this, next total. I'm just gonna add an extra, this is even slower. This actually looks okay. Let me see one thing here. Let's say I do 8, which is very close to my limit. No, it's still getting stuck at 3. I don't think this is improving it at all. I'm gonna do minus next T. Wait a second. Beep beep Discord message. Oh dang. All right. So if we have client A sending events to the server, 1. Okay. Let me buckle up and read this. If we have client A sending events to the server, 1, x0, x0, move left 1, 2, x minus 1, sorry, 2, x minus 1, y0, move left 1, 3, dropped event x2, y0, move left 1, x3, y0, move left 1, x4, y0, move up 1. Okay. I think I understand this. This is the client's positioning based off of his own inputs. The server receives all the events, but can interpolate events 1 to 4 as a single action over the combined DT. So after debounce, figuring out the delta, the server now has 2 events that need to be relayed to every client. x0, y0, move left 4 over DT3. X minus 4, y0, move up 1. Now in the case of dropped events from the client, like in the example of event 3, since we're assuming client trust, we can accept the following event 4 as valid. This might not be helpful at all, but at least I got to explain what I was thinking. No, you're good. I think one thing to keep in mind is that how it's set up right now is the server is the authority of all of the physics movements, and the client can kind of try to predict those movements. So really what would be happening is this computation would be happening on the server, and then we could be sending something like this to the client, if that makes sense. The one downside I see is that so I guess also to keep in mind is the debouncing is happening on each client. There's no like enqueuing of events on the server. The server is computing it as fast as it possibly can, and it's sending it to each client. So then the clients have to do the debouncing of the events that come in, but they're kind of debouncing the same way that you described. The problem though is if I was to do this, do it this way, the one downside is, well, sorry, let me just make sure I'm explaining this correctly. I get what I was about to say was that I think that this would cause some additional delay if the server was to do this, but I don't think it would. The clients, what they could do is they could extrapolate this logic and just keep moving the player left until they got an update that says, actually, the player moved this way. And I think that sort of behavior fits well into this priority queue that we kind of came up with. So like if user A hasn't changed their inputs at all, then like that's a very low priority update to resend user A, you know? So we might not need to send that to everybody else because their inputs are the exact same. So then the clients, what they would do is because like in reality, there's still tick 1, 2, 3, 4, and 5 in here. There's still all of those ticks. So there's a big delay between 1 and 2 and the 2 that you've written here. This is actually 5, you know? So there's still like 3 other ticks that happened there. So what the client would have to do, because he didn't receive an update for tick 2, the actual tick 2, so that says like, oh, this player is still moving left. What the client would have to do is he'd have to extrapolate that knowledge and just be like, well, the server didn't tell me the server didn't tell me that this player changed their behavior, so I'm just going to assume that they're doing the same behavior. And because I'm going to assume they're doing the same behavior for tick 2, the actual tick 2, I'm going to put them here. And then tick 3 happens, but it gets dropped anyways, let's say that packet gets dropped. He just extrapolates again. He extrapolates again. And then once the server sends to the client, oh, hey, by the way, like this player is actually over here and their current input is this. Now the client can stop extrapolating and then switch back to like, oh, well, I know where they are now and I know what their input is currently, and it can start replaying them from that position. So I think that works. I think this is a good idea. But I think it requires some sort of like priority queuing of messages to be sent out from the server to each client. And there is some challenge here with relying on the client to extrapolate, because like what could happen is, all right, let me do a new tab. I have a bunch of these windows open now. Let's say you have like a regionalized thing. That's like your vision. You're this person. And then this guy's running in. And you don't know that his input is left, right? Like this is the one desynchronization problem that could potentially happen. And this is kind of what I was trying to explain, where the server has to track what each client knows about. This is client 1, and this is like player 2, you know, which is a different client. So he's moving in, and the server's sending like, he sends the first movement update, right? He sent like this one, like, oh, he moved here, and his position's this. And then he relies on everybody else to extrapolate beyond that. What can happen is now this guy, when this message gets sent, or the initial movement message, which is this one, which is like he's moving left and he moved this far. This initial input message doesn't get sent to this client, right? Because he's outside of his region. So this client doesn't know about the extrapolation starting point that he should be working with. So what ends up happening is now he has to wait for like this client. Let's say he moves up right here. The player 2 does. Like if we were to just like the logic to be like hard, we only send differences. What's going to end up happening is this guy's not going to know about him until he gets there, and then he's going to teleport from here to here because he will have traveled the long distance. He's going to teleport from here to here, and that's going to be the next like extrapolation update point. And then from that point, you could extrapolate again. Does that make sense? But this is a reasonable strategy to do, I think. I think it would have to be fit into a priority queue though. And I think the logic should be less of a hard, we're not going to send anything unless it's a diff, to we're going to deprioritize. We're going to make that lower priority if something hasn't changed. So now you could be like, well, this hasn't changed, so it's a low priority. Then it hasn't changed, so it's a low priority. But it's like, actually, we've waited a long time. Like, this has been low priority for a long time. So it ends up becoming high priority just because we haven't sent an update for it. And then we send to this one. And then that kind of like improves like the interpolation, if that makes sense. There's a lot of very interesting like synchronization problems and stuff like that for sure. Use queue per area and make nearer area of higher priority to the client. Hence, you would know that player B is coming into your visual area beforehand. Oh, you're saying that like this would be one queue, then there would be another queue over here, or we'd probably have to like snap them together or something like that. So, sorry, I got called into a meeting and missed most of that. You're gonna have to rewind, I think. I'm supposed to be working. I'm glad I'm distracting you all day. Like if we made the regions hard like this, then yeah, I think Ivan, your solution would probably be fine. So then he would like player one would be needing to get updates. It would be like, oh, he's kind of close to this region queue, so we'll send him this stuff. But now it's like, oh, I have to know that this is higher priority for player one because he's close to the edge. It's like, do I send him the updates for every single square around him? But yeah, I think with the quad tree, that might be a little bit more tenable. By area, I mean smaller and smaller part, like censored country named doll. Yeah, I think I understand what you mean. Like you would have like these would divide up, you're saying. And then it's like, oh, this guy is like in this, he's in this one. So he should get updates from like, he should get updates from here, here, here. He should get updates from all of these ones. Yeah. And he gets it from his obvious one. The challenge there, I think, is now I have to dynamically, like the KD tree that generates this is going to have to like dynamically reallocate queues, which makes, I don't know, I'd have to think about this more. This might work. I think you have to rebuild the queue though if you ever like, if there ends up being a cluster of people. I don't know. I'd have to think about this more. I genuinely haven't thought about this problem too much. I think this will be lower. This will cause more I don't know. Not really. Just divide the map into queues and of smallest segment visible on screen and build from there. Oh, you're talking about like a spatial hash? Yeah, I mean that just, yeah. No, that's doable. The problem is if you make the spatial hash too big, now you have a bunch of regions you have to send from. But I guess there's different ways to solve this. I don't know if I'll go with this route of regionalized queues, unless it's like, I don't know. I have to think about this more. I'm not sure. Oh, this is a Bungie one. Destiny has an extremely complex networking model. I like that. What a great start. Stadia players. I thought Stadia died. I'll read this later. The crash propagator. I'll read these. Thanks for sending them. All right. I'm probably gonna call it here. I think we're close to where I need to. I just need to tweak these. I need to balance the things. Leaked Discord. Oh no. Uh-oh. Is that bad? I feel like I've been showing this for a while. I hope there's nothing. I don't think there's anything on here that's bad to show. Networking is honestly my favorite part of being a dev. Yeah, I think it's pretty interesting. Also, welcome Torn to the stream. We Seifu? Now I'm just messing with you? Okay, good. I was like, oh crap. Only the only newts? Yeah. Apart from AWS shit, hate that stuff. I don't blame you. I think the big problem, connecting stuff is fun. Yeah. I'm glad I didn't leak too much. I think the biggest problem of like this era of computing is like how you manage a big cloud infrastructure project. I feel like most of the stuff's been pretty solved. Like most things are like pretty figured out. Even like the stuff I'm doing, like people have already kind of figured this stuff out, and I'm just like stealing it from them. But I feel like there's a bunch of there's like Terraform, there's CDK, there's CloudFormation, there's all sorts of stuff. I feel like it's not ever really been solved super well. I've never used Terraform though before, but I told you it was a language. Jomi's gonna have to solve his it's dry principle, don't worry. Jomi's gonna have to solve his advent of code in Terraform one day. I can't wait to see that one. Guess I have to now. Is it Turing complete? Oh wait, we're already subtracting this out. Yeah, I'll have to tweak these because I think it's working. It's pretty stable now. The only thing is like managing the buffer size is what I need to figure out next. So I'll probably work on that for the rest of the day. But I'm gonna go eat lunch. But it was fun. Thanks for all the chatting. It was a good time. I'm glad we finally got this a little bit closer. Feels good. Thank you, buddy. Thanks for popping in. I'm glad I was able to distract you from work for a little bit longer. Later to you as well. Afternoon grub, exactly. You want to get a sub? Been enjoying the channel? Glad to hear that. Good, I'm glad it was a fun stream. I'm glad everyone's enjoying it. I enjoy it too. Yep, I'll see you guys all later. You guys have a good one. Bye.